Hello, my name is Maureen Cavalaris. I'm the Head of Translational Cancer Nanomedicine Group at the Children's Cancer Institute. Children's cancer is the #1 cause of disease-related death for children in Australia. So it can be very difficult to identify which drugs are going to work the best and which ones are not. And one of the key challenges is that we often don't get a lot of sample from the patients. We get very small biopsy samples. You can barely see them at the edge of the tube. And we have to actually figure out ways to grow these tumour samples. And our laboratory here at the Children's Cancer Institute has developed a way to grow many tumours from the patients without actually touching the patients. So we can make hundreds of the patients' tumours using advanced technologies, including the bioprinter here that you can see on my left. And we can actually bioprint these tumours, make them identical, make hundreds of them. The idea is to do a drug screen on these samples, identify the right drug for the right patient at the right time. But what's unique about what we're doing is we're actually growing these tumours in an environment that's very similar to how the tumours are growing in the body. So we grow them in a jelly-like structure that allows them to grow and expand and support their growth, while still being able to screen these patient samples. So we've just published a research paper that has actually shown that we can bioprint and grow these patient tumours in the laboratory, expand them and do this high-throughput drug screening and identify which drugs they're going to respond to and which drugs they won't respond to. So this is a very exciting advance in this technology because it's the first time people have shown that you can grow the paediatric cancers in this way and expand them. And in this first paper, we focused on neuroblastoma and sarcomas, but we also know from our other work that we have now been able to expand into other tumours, including brain cancer. So our next steps now are to work with the clinical team to align this with a clinical trial and be able to get patient samples directly from the patients and be able to expand them and bioprint them so we can see whether this technology will be able to give us very effective prediction of which drugs the patients are likely to respond to. I really want to say a big thank you to the Cancer Council for supporting this research that's allowed us to get to this point, and I look forward to advancing work even further in the clinic.